Hi, I'm Emily from emilylearning.com. In this video, I'll be going through question 11 of the 2023 H2 A-Level Paper 1. This is a question on AP and GP. To find the full work solution, you can find it here at this website here. I'll provide the link in the description below. So now let's go to this question now. Okay, so in this question, Wei is saving for a property that she intends to buy in the future. So to do so, Wei needs to save a minimum of $50,000. So she saves regularly in an account which offers no interest. She makes an initial deposit on 31st January 2021 of $8. Each subsequent month, she deposits $50 more than she deposited in the previous month. Her final deposit is made on 31st December 2023. So for this type of question, one look, you know that it's either an AP or GP question. Okay, and you have the beginning the deposit made at the each month. Okay. So for this type of question, it will be easier to set up a table, okay, and then to see the pattern and answer the question subsequently. So let's set up the table here. So I'll set up a table with 3 columns. Okay, the first column being the month. Okay, the second column being the amount deposited. And the third column being the total amount in the bank. Okay, so these are the 3 columns. So I'll define month 1 as ending on 31st January 2021. And I know that in month 1, okay, Wei has deposited $8. Okay, and because the bank does not give any interest at the end of month 1, there is $8 inside the bank. Moving on to the second month, which is the end of each month, she deposited $50 more than she deposited in the previous month. So the amount deposited in the second month is $8 plus 50. Right? So the total amount in the bank will be A plus, this is the amount at the end of the first month, and then this is the amount deposited, so it will be A plus 50. So the total amount deposited, or the total amount in the bank at the end of the second month will be 2A plus 50. Okay. Next, let's move on to the third month. So in the third month, she would have deposited A plus 50 plus 50, or in other words, A plus 100. At the end of the third month, she'll have this amount plus A plus 100. Okay, so it'll be 2A plus 50 plus A plus 100. So if I were to sum them out, I have 3A plus 50 plus 100. I can still continue. So on the 4th month, okay, the amount deposited would be A plus 100 plus 50, which is A plus 150. Okay, and the total amount in the bank will be what there was at the end of the previous month plus the amount deposited. So it will be 3A plus 50 plus 100 plus A plus 150. So I can simplify it into 4A plus 50 plus 100 plus 150, and so on. If we were to follow this pattern here, you know that by the by the 12th month, where it will be 31st December, okay, she would have saved. So if you look at the first month, it is A. Second month is, you have 2A plus 50. Third month, you have 3A plus 50 plus 100. Fourth month, you have 4A plus 50 plus 100 plus 150. So on 31st December 2023, okay, we know that this portion here the first part will definitely have a 12A, right? Because first month you have A, second month you have 2A plus blah blah blah, third month you have 3A plus blah blah blah. So we know that on the 12th month it'll be 12A. Okay, then you have 50 plus 100 plus so on. We know that, okay, the first month there is nothing here, no terms here. The second month there's one term without A here. The third month there are two terms with A here. The fourth month there are three terms, 50, 100 and 150. So in the 12th month there will be until term 11, right? Okay, so it's 50 plus 100 plus 150 all the way until the 11th term. And we know that this portion here forms a AP, okay, with the first term being 50 and the common difference being 50. So if I were to sum up this here, so I know that at the end of December, okay, I'll have 12A plus 50 plus 100 plus 150 all the way to the 11th term. And this is an AP with 11 terms. Number of terms is 11. The first term is 50. The common difference is 50. So to sum them out, it'll be equals to 11 over 2, n over 2. Okay, 2 times 50 plus n minus 1. So n is 11, n minus 1 is 10 times 50. And I know this will give me a total value. I want it to be at least, okay, $50,000. Okay, so based on this, we just need to solve this to find what is A. Okay, so if I were to solve this equation here, I will obtain a value of A equals, okay, so solve this. So you just need to find this portion here, then take 50,000 minus this, then divide by 12, right? So solving for A will give me, okay, $513.89. All right. Okay, so this portion here is $31,500. Okay. Now that we have found part A, let's move on to part B. So in part B, Wei has arranged to purchase a property on 1st January 2024 with the aid of a loan of $400,000. The terms of the loan are that interest of 0.1% is added to the amount owing at the start of every month, with the first interest amount added on 1st January 2024. Wei made a monthly repayment of X dollars at the end of every month, with the first repayment on 31st January 2024. Okay, so now you are asked to show that the amount in dollars that Wei owes at the end of n month is this amount. So to do this question, we need to set up a table again. So now we'll start off with the month. Which month is it? First, second, third. And the first month is denoted as January 2024. And in this question, it talks about beginning and end, right? Okay, amount. So we'll write amount at beginning of month. Okay, this is at the beginning of the month, there will be a 0.1% interest that is being added. Okay, then we also have amount at end of month, okay, where Wei will make a repayment of X dollars. Okay, so now that we have set up this table, okay, let's write out what we have. So at the beginning of the month, okay, the interest is added. So on 1st January 2024, she hasn't made any payment, right? So she still owe a total of $400,000. So it'll be $400,000. And then there's an interest of 0.1%. 0.1% is equals to 0.1 over 100, which is equals to 0.001. So the amount that she owes will now becomes 400,000 times 1.001. Okay? Then at the end of the month, she made a repayment of X dollars. So the amount owed will be $400,000, 400,000 times 1.001 minus X. Okay. Now let's move on to the second month, which is February. So at the beginning of the month, this amount here will be charged interest. So the amount of interest will be 1.001 times 400,000 times 1.001 minus X. Okay, which will give us 400,000 times 1.001 squared minus 1.001 times X. Okay, then at the end of the second month, okay, it is the amount, okay, will simply be this amount here at the beginning of the month minus X, because Wei makes a repayment of X dollars. So it'll be 400,000 1.001 squared minus 1.001 X minus X. Let's move on to the third month. So for the third month, okay, this amount will be charged interest. The amount at the end of the second month will be charged interest. So I'm going to multiply 1.001 to every term here. So I end up having 400,000 times 1.001 cube minus 1.001 squared X minus 1.001 X. Okay, then at the end of the month, okay, it will be this amount minus X, because Wei makes a repayment of X dollars. So $400,000 okay. So now let's take a look at nth month. So at the beginning, because I'm interested at the end of n months, right? So I just write at the end of n month, so I can ignore this. So at the end of the n month, I know that based on this pattern here, you notice that there is this term here that has 400,000 times 1.001 times with a power. So when it is the first month, this 1.001 has a power of 1. When it's the second month, this has a power of 2. When it's the third month, this has a power of 3. So at the nth month here, this portion here will look like 400,000 times 1.001 to the power of n. Okay, because when here is 3, here is 3. So if when here is n, here is n. Okay, next, we know that you still have this portion here, right? Okay. In the first month, there is one term here, which is x. In the second month, there are two terms here, minus x and minus 1.001x. And if you take a look at this, this looks a bit like a GP, right? Because this term and this term differs by the ratio 1.001. So you multiply x by 1.001, you get 1.001x. And then you go on to the third month, there are 3 terms here. Okay, and you have x, 1.001x and minus 1.001 squared x. Something like that, right? So we know that on the nth month, right, okay, we will also have n terms here. So if first month you have one term with x here, second month you have two terms with x here, third month you have 3 terms with x here, right? Nth month you have n terms with x here. So we know that there are n terms here. Okay? Then we know that, okay, the last term, okay, will have a power that is 1 less than the month. So if the month is 3, this power here will be 2. This is the second month, so the highest power of 1.001 is 2 minus 1, which is 1. So we know that for the nth month, here will be minus 1.001 n minus 1x. Okay, minus 1.001 n minus 2. Okay, x, okay, all the way to minus 1.001x minus x. Okay, and I know that there are n terms here. From here to here, there are n terms. Okay, so now if you take a look at this, let's just assume this is the first term, x, 1.001x, and so on, and this is the last term. So there are a total of n terms. The first term, let me call the first term A, is negative x. Okay, and the common ratio is 1.001. Okay, because to go from one term to the next, you multiply the preceding term by 1.001. So in other words, this is a GP, and to sum a GP, okay, Sn is equals to a r to the power of n minus 1 over r minus 1. So this is how I'm going to sum this portion here. So at the end of n months, okay, the amount will be this, right, which is equals to 400,000 times 1.001n. Okay, and then I'm going to sum up this GP. So this GP, okay, has a first term of negative x, right? So I put my minus here already, so my x is here. R to the power of n, so the common ratio is 1.001, the power of n, minus 1, over r, which is 1.001 minus 1. Okay? So 1 minus 1.001 minus 1 is 0.0001. So 1, so okay, so this part I already got it already, right? So I'll write it the way the question gives me. Okay. And this, something over 0.001 is basically 1 over 0.001 is equals to 1,000. So I'll just change this to 1,000. So let me erase everything. Okay, so I've shown this, the amount at the end of n months. Moving on to the next part, suppose the loan is repaid in 360 monthly repayment. Find the value of the monthly repayment to the nearest cent. Okay, so in other words, right, I know that the loan is repaid in 360 months. So by the end of the 360 months, right, so by the end of 360 months, this must be equals to the the amount owed at the end, okay, should be equals to 0, right? So I will equate this to be equals to 0, and I know that because it is paid in 360 months, this n is equals to 360. Okay, so what I'll do is when n is equals to 360, I know that this is the amount that is being owed. Okay, so basically what I did is I sub n equals to 360 here. Okay, then I know because the loan is repaid in 360 months, so the amount that is owed is 0. So this will be equals to 0, right? Okay, then I will just need to solve for this. Okay, so solving for this, okay, will give me x equals to $1,323.6347. So nearest cent, so 1323.63. Okay, so that is the answer for this part here. Next, I'm asked, use your answer in part C to calculate the total interest paid on the loan in this case. Okay, so now I know that X is the amount that is paid each month, right? So in order to finish paying the loan in 360 months, we would have to pay $1,323.63 each month. Okay, so the amount of interest paid, okay, total interest paid is simply equals to total paid, right, minus the loan. And we know that the loan is $400,000. How much did she pay in total? We know that each month she paid 1323.63. And she paid it over 360 months. Okay, so in total, okay, put this into your calculator, you know that the interest that is paid is $76,506.80. Next, now suppose Wei decides to repay the loan at a rate of $1,600 per month for K months, plus a final repayment of Y dollars, where Y is lesser than $1,600. Find K and Y. Okay, so now what does it mean? So we know that okay, so she's going to pay $1,600 for K months. Then finally she's going to pay Y dollars. Y dollars is basically maybe there's a certain amount that's lesser than $1,600. Okay, so she just pay it all up so that she doesn't need to owe it for another month. Okay, so what we can do here is we can still make use of this portion here. So recall this is the amount owed at the end of the n months. So let's assume that she's going to pay this amount at the end of so this is the amount owed at the end of n months, and X is the amount that she repays, right? And we know that in this part here, X is $1,600. So we know this is X. So X is equals to $1,600, and we have $400,000, 1.00 to the power of, now instead of n I have K months, so I'll just put it as K. Okay, minus 1,000 X, okay, 1.001 K minus 1, right? This is what this is the amount that he owes at the end of n months. So now if I change from n months to K months, I just change the n to K. And the question also tells me that the X is 1,600. So I replace the X by 1,600. Okay. Then I know that at the end of this month, there's also a final repayment of Y dollars. So that means after here, Y dollars is left. So in order to replay it, okay, I need to minus Y. Okay, then it will be equals to 0. I also have another criteria, Y is lesser than 1,600. So now I'm going to put in X equals to 1,600. Okay, so if I put in 1,600, it'll be, this is, okay. Okay, so I need to solve for K. I need to solve for Y. So the easiest way is to type this into your GC. Okay. Okay. So instead of writing here equals to Y, I'm going to replace this. All right, Y equals to this amount. Okay, and I know that Y is lesser than 1,600. So I'm going to use my GC. I'm going to type this as a function. Okay, and I'm going to search for the Y value such that it is lesser than 1,600. Okay, so by GC, okay, I have K here, I have Y here. So when K is 286, I get Y being 2917.300, which is still more than 1,600. When K is 287, I get Y being 1320.217, and this is exactly what I want. So if I move on to K being 288, I'll have negative 278.461. So repayment cannot be negative. So therefore, the value that I'm looking at is K equals to 287 and Y is equals to 1320.22 cents when corrected to the nearest cent. Okay, so this is the answer. The easiest way I feel is by using the GC. Okay. Okay, next, hence find the total savings to weigh by making the repayment in part D1 rather than the repayment in part C1. Okay, so in order to do this, so let's find out how much interest did Wei paid. Okay, interest paid, okay, in part D1. So in part D1, right, the monthly repayment is $1,600 made over 287 months. Then finally, she also paid $1,320.22. So the amount, total amount paid is 1,600. Total paid minus loan. Okay, so the total amount paid is 1,600 multiplied by 287 months, then plus the last repayment, which is $1,322.22. Then we know that she loaned a total of $400,000. Okay, so this will tell us that she loaned $60,520.22. Okay, now we are going to compare this with the interest paid in C part 1. So we know that the interest paid in C part 1 is $76,506.80. Okay, so now he only paid an interest of $60,520.22. So he actually saved, okay, this amount, right? So you just subtract them. Okay, so it will give me $15,986.58. So 4 significant figure will give me 15990. Okay, because here it asks us to leave the answers to 4 significant figures. So basically, this is the question 11 of the 2023 H2 A-Level Math Paper 1. For this AP&GP questions, right, typically you just need to set up a table. Okay, and you will, so basically, as long as you're able to set up the table for part A, as well as to set up the table for part B, okay, the rest of the question is basically just applying what you have found in part B and understanding it, right?